So Steve George, UAS Integration Office.
Good morning. Good morning, everybody. My name is Steve George. I'm here with the UAS Integration Office. I'm here on behalf of my boss, who is at Oshkosh this week, and I'm humbled to be amongst such an esteemed panel, and hopefully I can stand up and meet to the level that we have up here. I currently manage the airworthiness section in the Unmanned Aircraft Integration Office. That's mostly the engineering staff working with our colleagues in aircraft certification and the NASA Enterprise Architecture, Next Gen, and the Air Traffic Organization, trying to understand and make progress on some of the technical underpinnings that plague the UAS industry. I'd like to start off with a little bit of history. I do have pretty deep background in unmanned aircraft, over 10 years, starting with Air 130. And there was an event back in 2004, roughly, time frame, where a group of us went out to Fort Huachuca to see the observe the operations of the Hunter and Shadow operations out there at Fort Huachuca. And there was a belief then that, hey, there's no people on board, so there's no human factors implications at all. Well, that's not true. Colleen Donovan was out there with us. I don't know if Colleen is here today or maybe watching, but she brought up all kinds of human factors issues as she, it was her first foray into the unmanned aircraft. And she brought up things like the primary flight displays, like the basic T that we're all familiar with, mode awareness, caution and warning, enunciation, operational procedures, and Bill touched on a lot of these things. In addition to things like menu layering, use of colors, and the pilot physically not on board to sense what's going on in managing the aircraft operations. So that was kind of like the first, hey, there are a lot of human factors issues associated with unmanned aircraft. Early, UAS became kind of a victim of their own success because they were initially technology demonstrators for the military and public aircraft operations, and they provided so much now operational capability that they were fast-tracked through the system. And my belief, and I think it's shared by most of the folks, that the engineering and development process was fast-tracked to get that operational capability for many different public aircraft operators. One of those short circuits, so to speak, was a disciplined look at some of the human factors and seeing the flight crew interface to a brand new technology and capability. Fast forward about 10 years, and this wasn't too long ago, there was a relatively large UAS, I won't say which one or operated by whom, flying relatively high. Everything was normal, and then something odd started to happen, and the UAS had a fairly rapid rate of descent. And the pilot was a bit confused because he was seeing large rates of descent and a very slowly increase in airspeed. So he was confused with what was going on by the information that was provided him. As it turned out, what happened is the aircraft, because of the way that the flight controls, and particularly the throttle controls, were involved, it went into beta mode, which means that the prop went into a pitch to provide reverse thrust in flight. So there came the result of the high rate of descent and not rapidly increasing airspeed, which became confusing. The problem was that the beta indication on the display was a white circle that showed the pilot it was in beta mode. But the aircraft's screen was against a white background with clouds, so he had no indication that the aircraft was in beta. And of course, by the time several thousand feet below, it resulted in a loss of control and crash. But I think it highlights something very simple in terms of human factors and the pilot getting the information that he needs. We've come a long way since then, and now we're going into the civil environment. And there is a wealth of human factors guidance, tools, processes on the design of aircraft that are directly applicable to UAS. My view is that we have a threefold problem that we're having to deal with now. First, is dealing with the legacy equipment that were rapidly fielded, and they didn't have or afforded the human factors discipline in the design and operation. Second is education of our new entrants, especially for the civil world, to let them know there is a plethora of information, guidance, and processes to assist in incorporating human factors into the design. The third is the new human factors unique issues. Things like automation and autonomy, and how the pilot functions are allocated between the aircraft automation and the pilot himself. Workload assessments become a big part of that. Mode awareness is a big issue. Display of the flight information for essential flight information versus what's referred to as situational awareness. It's a dirty word to me, but okay. And then how to replace things with pilot eyes. So pilots do a lot of things with natural human vision that are going to be replaced with new sensors and computers and displays. How do we prove that those things are sufficient, and how do we get them authorized for use? So that's just my perspective in how I've seen things mature over the past few years. And I thought those would be useful in terms of opening up with some human factors related stuff. Now, given that we are the UAS Integration Office, our mission is to lead but not own. We basically work with all of the policy offices and the staff offices across the organization to ensure that the right material is being developed at the right time and assist those organizations like aircraft certification, flight standards, air traffic, and trying to homogenize and make sure that things fit well and that it works together like a well-oiled machine. That's the vision. We are still in the process of congressional reprogramming that will recognize our office. And Earl Lawrence is our senior executive director. Bill Crozier is his deputy. And then the entire organization will fit in as soon as the congressional reprogramming is out. The first thing that we've got that's come out recently is our final rule on Part 107, which is operations for small UAS. It basically goes into effect and becomes effective on the 29th of August, if I'm not mistaken. And our current Section 333 operators, which are basically exemption holders, can operate under the conditions and limitations of their 333 and operate under the Part 107. They can't really mix and match from the rules. If they remain under 333, then the conditions under their 333 approval still apply, and they have to operate under those conditions. Some aspects of the 107 rule, it's non-recreational operators. They have to hold an airman certificate. They have to be 16 years of older, and they have to pass a TSA screening. The rule doesn't change any guidance or regulations for hobby aircraft. So the hobbyists will be able to operate as they have in the past. The remote pilot certification is basically just a knowledge test in the TSA background check. As far as the Part 61 pilot certificate holders, they have to hold a current pilot certificate issued under Part 61. They have to complete the training course on the FAA Safety Team website. They have to complete an 8710-13 Airman certification form, and then contact the FSDO and an FAA designated pilot examiner, and I guess that's an Airman certification, ACR, or an FAA certified flight instructor to make an appointment. The FSDO, DFE, or ACR can then issue a temporary RPC while the permanent is mailed. So that's the existing Part 61 requirements. Under the Part 107 small UAS rule, there's an online training course for Part 61 pilots, and it covers applicable regulations relating to small unmanned aircraft, effects of weather on aircraft and performance, small unmanned aircraft loading and performance, emergency procedures, crew resource management, determining performance of small unmanned aircraft, and maintenance and pre-flight inspection procedures. The basic operating requirements under Part 107 are that the UAS must be under 55 pounds, maximum operating altitude of 400 AGL or less, maximum airspeed of 100 miles per hour or 87 knots, that the operations are limited to Class G airspace, visual line of sight, no operations over people, must yield right-of-way to manned aircraft, one operator per UAS at a time, and external load operation only permitted if they don't affect flight operations or control. So I think with that litany of limitations, you immediately see the limitations in terms of the utility that the rule provides. So it's great for the small UAS, the quadcopters, the things under 55 pounds, and it provides for commercial operations as well, so they can go in and make a profit out of the operations that they're doing. But there are a lot of things beyond that the industry is looking. Things like beyond visual line of sight, operating directly over people, operating at night. And we have a number of initiatives within our office that are working that. We've got the micro UAS ARC. They're working on trying to establish what would be the criteria to operate under Part 107 directly over people? The approach that is being taken now is a kinetic energy approach, basically trying to say what kind of damage or serious injury could occur if it fell directly on top of a group of people. The further one is looking at what are repeatable processes, and that's under one of our Pathfinder projects, to establish what would be required for them to routinely operate directly over people safely, without the other limitations like weight, visual line of sight, or sorry, weight, and altitude restrictions. Another one of our Pathfinder efforts is looking at extended visual line of sight. So, its general applicability are things like operating over crop fields and not densely populated areas where you're trying to do some kind of activity like crop inspection, where you can operate beyond your ability to see the aircraft, but augmented by some kind of displays or other risk mitigating procedures, such that you don't pose a hazard to other people and property on the ground or other users of the airspace. Our third Pathfinder is looking right at beyond visual line of sight operations. What does that require? How do you get the aircraft to operate where the pilot can't see it, has no direct acquisition of the environment of where it's operating, and how can it be conducted safely? That has implications on the C2 link, has implications on detect and avoid capability, has implications on pilot information for primary flight control, et cetera, and figuring out what that balance and relationship is between automation and pilot functions. Last thing I'll talk about is some of the research activities that we have going on. We have an entire research division within the AUS organization that works with our partners in ANG and the research executioners, our Center of Excellence, and our UAS test sites in performing, collecting, and analyzing research data to try and inform policy development, future rulemaking, development of standards, how we do methods of compliance for things that are unique to UAS. All that research is being managed through our research division and worked closely with the offices like Aircraft Certification as the sponsors. We have our own sponsored research, other organizations like the Air Traffic Organization, and being sure that we're getting the right research data in to inform the policy, rules, and guidance that we need to develop over the course of the next few years. We're also working with partner agencies like the XCOM to align research priorities across government. The Integration Office is developing a research inventory mapping database to be able to engage and broadcast a set of external stakeholders in the UAS community to collect and share the research-related data externally to our other stakeholders. 4 key areas of research have been identified in the human factors research area, and that is function allocation, control station requirements, pilot training and certification requirements, and visual observer requirements. Our partners at the Alliance for System Safety of UAS through Research Excellence, which is ASSURE, if you've heard that before, and the Center of Excellence include Drexel University, University of North Dakota, New Mexico State University, and Ohio State University. So in a nutshell, the objective here was to kind of cover what we as the Integration Office are involved in that influences or informs or requires input from the human factors community. And at the end of the panel, I'll be happy to answer any questions that you may have as a result. So thank you very much for your attention. On to you, Bill.
Very good. Good morning, everybody. My name is Bill Davis. I'm the Executive Director for Emerging Technologies for the Air Traffic Organization. And as you can imagine, my interest and concern is not so much with the individual platforms like Steve was just talking about, but more how do you take those platforms and then operating in the National Airspace System, otherwise known as the NAS. The NAS is really a system of systems, and it's dominated historically by manned aircraft, and the operation of those manned aircraft have typically been point-to-point operations, airport to airport. And for the last 70 years or so, we've really focused a lot of energy on making those airport-to-airport operations as efficient and effective and safe as possible. We've done a ton of human factors research around pilot to controller, controller to pilot, pilot to pilot, all the different things about operating manned airplanes in a point-to-point system which attempts to maximize the delivery of airplanes, manned airplanes typically, and helicopters and so on, of course, between airports. Now enter UAS, and airports are of some significance to some UAS operators, the big ones, particularly if you're looking at cargo operations and those kinds of things. But for the majority of many operators, airports are not a necessary part of their operation. To some degree, you could argue that they get in the way. And so we're going to talk a little bit about kind of how we integrate UAS operations into a manned operating system, into the legacy system, which has to continue. The legacy system is critical to the economic, defense, security aspects of our country, and it needs to continue, and we need to allow it to grow and improve safety and do all those things while we intertwine this whole new emerging technology of unmanned systems. So I would say, while you just heard a lot of research about things that are going on for developing the platforms, regarding interoperations in the NASA, I'm going to say we don't know what we don't know. I mean, it's not like that we know nothing. I mean, we have a history, a rich history of research with controllers and pilots operating manned airplanes. What I'm proposing is we need to look at those pieces and look where we've had big returns and made big gains, and some of them are pretty obvious. And what I would say is I would challenge the research community to start looking at this and approaching the operators of the system that, have you considered this? Have you considered this? If you sit back and wait for us to come to you with a research plan, we're probably way too late in the process. So we need you to be much more proactive in thinking about this and looking at the history of the manned system and say, for example, phraseology. So there's phraseology that we've worked for 70 years on in the man, and we get pretty good. There's still issues with it, if we have time later on, there's great examples. But phraseology is an interesting one between controllers and pilots. Well, now there's phraseology that may not even, that probably won't be spoken, which has kind of been the historical process until the arrival of Datacom and other things. Much of the phraseology has been a controller talking to a pilot. Well, now we're going to do it via link, Twitter or email or whatever link you happen to be on, and we have the community that is entering the system now, many of which are not aero or NAS savvy, if you will. They don't necessarily come with a huge background, and have not gone through the huge barriers to entry that the legacy system imposed on people. If you wanted to be a pilot in the legacy system, you had to go to flight school and make some investment and get some experience. If you wanted to be a controller, you had to get hired, make it through the training, which is rigorous, and get some experience and build that. If you wanted to be a mechanic, same thing. If you want to be an airplane owner, big barriers, very expensive, fuel's expensive, maintenance expensive, big barriers to entries in the legacy system. That had a modulating effect on kind of who was in the system. If you were operating in the NAS, you pretty much had skin in the game. You had an incentive. Now, a couple $100, a credit card, a 12-year-old can get out and buy a really cool system at Sam's and be flying the next afternoon. I mean, so the barriers to entries are gone. So we have a huge challenge in front of us, educating the nation, if you will, maybe the globe, I guess probably the better way to look at it, on how this UAS system, which we all want to grow and flourish, and we all see huge benefit in. I don't think anybody can test that. But it has to grow and flourish and emerge in a way that allows the manned system to operate and grow and flourish and thrive and survive and so on. So that's from the ATO perspective, I submit that's the real challenge. It's emerging the different systems. So there's things like just simple things that we all have. I mean, I'm a pilot by background, so I know and have focused on things like phraseology, a very basic one. Another one is how about let's talk about just distraction. We know that's a long-term human factors issue. The current legislation calls for UAS operators, Steve mentioned modelers, if they want to operate within 5 miles of an airport to notify the airport authority and the ATC facility if one's available. Most people interpret that as call. Well, that's a little problematic from the ATC side in that we don't manage traffic via the telephone. We have a whole infrastructure to set up with radios and frequencies and flight plans and all those kinds of things with which we manage the manned system. And now you potentially interrupt, or you potentially inject a whole new kind of operating paradigm that has not been kind of reviewed, studied, analyzed. And distraction is probably one of the most fundamental things that we know is a human factors problem, either interrupting checklists, interrupting workflows, interrupting controllers, managing multiple airplanes, and so on and so on. So the human factors from a NAS systems point of view is replete with human factors work that needs to be done. And we need human factors specialists to wade into that and say, this is the highest value work that paid off in the pilot world, in the airplane, the manned airplane world, rather, between controllers and pilots. And we're likely to repeat the same mistakes with UAS, whether they be human in the loop or autonomous. Another one is rules of the road. So you have a UAS and a manned airplane come at each other. What are the rules of the road going to be? Are both people going to turn? Are both people going to climb? Are they going to climb and descend? Is the manned airplane not going to move and the UAS going to move? All questions that need to be answered, and we haven't even answered the sense and avoid question, which will allow all that stuff to happen yet. So tons of work that needs to happen in order to integrate the kind of the UAS into the system in a kind of in the way that most people can see it. We've all seen the Jetsons cartoons with airplanes, buzzing all around, and that may be the vision of the future 50 years from now. But to get there, there's a lot that needs to happen, and we're not doing it. And this is, I believe, the biggest challenge. We're not doing it in a blank slate with a clean sheet of paper. We're doing it amidst a system that is already very busy, and already is honed and tuned with years of infrastructure and procedures and policy and training that needs to be incorporated into the introduction of this UAS phenomenon, if you will. And I call it that because the larger system over let's say the last 70 or 80 years, certainly since World War II, we've produced a national airspace system which most people, I think, agree is the best in the world. It basically supports the operation of about 600,000 pilots. That's how many are generally, just in round numbers in the registry, and somewhere between 250 and 300,000 airplanes, depending if you include light sport and some other things. So say 300,000 airplanes, because that's kind of an easy number. So at any one time, typically maybe 8 or 9, 10,000 on a busy day are flying at any one time. So the entire NAS basically is built to support 300,000 airplanes flown by 600,000 people, of which 10,000 are in the air at any one time. Since December, we've already signed up more than 500,000 UAS operators. And it's likely that many of them own more than one UAS because they're so inexpensive. So there's already as many UAS operators, or just about as many. Well, we know there's probably more because not everybody signed up in the registry. There's already more UAS operators than UAS potentially in the system than there are manned airplanes. So, and we also know that our big Core 30, Core 40, 50, 60, our big airports, say the top 100, are pretty busy during their busiest hours when they're pushing, and as a result of that, delays are already occurring. Now you start adding the introduction of large numbers of UAS into the system, and we have to figure out what all that looks like and kind of what the priorities are and how we allow both systems to operate. So there's lots and lots of work to be done, and I would challenge that we have some really good clues out there on how to look at where the highest value work needs to be done in the systems operations from the system operations standpoint. So I'd ask that you be proactive, that you pick topics that are operationally focused. So the nuances of human factors and around kind of arcane topics, they're of interest to all of us, but I need people to focus on the big items. Is the phraseology correct? Does a 12-year-old or a 16-year-old who's receiving a phrase via Twitter or email or some other electronic means, does that convey the meaning, the information that we want it to convey? If it doesn't, what backup information needs to be available, and how do we deliver that, and how do we display that, and all those kinds of things? I mean, the communications piece is a big one, because there are potentially millions of UAS operators out there, and there will be much of this communications will need to be done in a scalable way. Read scalable as automated, because we simply can't hire enough people to manage all these phones. And so we're moving into a different operational control paradigm, if you will, that needs some serious review and serious thought as to how we make systems scalable and effective to allow the UAS industry to flourish. And I think we want that to happen. It's to our national advantage. There's lots and lots of good that can come of this, but we have to do it in a way that allows the manned system to operate. So let me just close by saying the operational focus is important. We do not want to start adding things to controllers, adding work to controllers that distracts from an already very busy schedule, particularly in our top 100 airports. A busy workflow. So if we're just going to kind of move into an ATC facility and expect that this is one more thing that will just be absorbed, not so fast, because I'm not so sure that that's the right way to do that. Maybe we want to manage these operations in a different way. Again, human factors work needs to be done to try to understand what the best approach is, and also what systems look to be scalable and what systems look to be effective. The need to prioritize this and do it relatively rapidly is preeminent, I would say. So I'll close by talking about the 107 rule. So the 107 rule, this is D-32. The 107 rule goes effective on August the 29th, the small rule. What that means is that, and I handed these out so you'll understand this piece of it. So it means Class G airspace, uncontrolled airspace. You'll be able to fly a UAS without asking. We can all go out and buy one and just fly it in Class G airspace 400 feet and below. About a month after that, we hope to move into Class E airspace below 400 feet. That's the non-towered airports. And then about a month behind that, into Class D airspace. That would be small towered airports, typically VFR, small VFR airports. And then a month after that, Class C, and a month after that, Class B. Class B are the biggest ones. It's New York and Chicago and those. So how we manage that, and there's rules in line of sight, and Bill or Steve went through all those things. How we control that is very important, but there will be a steady migration into airspace across the country, 400 feet and below. But there'll be waivers to do other things, to go higher than that, to operate at night, and then the UAS migration into the airspace system, into the NAS, will be controlled by a rules-based cadence, and Steve mentioned these. So this is the small rule, goes into effect August the 29th. D-32 is today. After that, several months later, there'll be the ops over people. That's the ability to operate over people with UAS in a risk-based way, and Steve mentioned that. Then after that will be the one which is replete with human factors issues, and this is the extended operations beyond line of sight. So there's lots to do here, and then after that, it's not clear yet what the next piece would be. I think based on some serious thought that you may have influence on what the next piece what the next rule ought to be. Is it cargo ops, or is it package delivery, or is it something else? We haven't decided yet, but we're actively thinking about it, and we'll be using a rules-based process in a semi-annual to annual cadence to migrate processes and UAS into the NAS in a more and more comprehensive way, and each of these individual migrations will require substantial thought, human factors consideration. So your work is here to stay. We're just asking you to be very proactive and engaged. Thank you. Oh, sorry.
So my name's Ed Wagoner. I'm the Director of Integrated Aviation Systems at NASA headquarters. I want to thank Bill and Nick for setting up this forum and allow us to talk a little bit about the research that we're doing. And just to give you a little bit of context of where we sit in the NASA hierarchy, NASA is basically broken down into 4 mission directorates. We look at science, we look at human exploration, we look at space technologies, and then we look at aeronautics. And so we reside in aeronautics, and aeronautics is broken down then into 4 directorates. And so my boss reports to the administrator reports to the president. The 4 areas that my boss is responsible for: airspace operations, advanced vehicles. We've got convergent and kind of nascent technologies that we're doing research on, and then integrated systems, and that's my responsibility. And I've got a fairly broad portfolio. So in addition to the unmanned aircraft work that we have going on, I'm responsible for all of the flight-related capabilities that NASA Aeronautics has, as well as what is going to be a series of X-planes that we will build and fly to test various advanced technologies for commercial aircraft. And we just finished work relative to environmental and responsible aviation, where we were looking at advanced technologies to reduce fuel burn, noise, and emissions for advanced commercial aircraft, and work very closely with the FAA and the decisions and some of the research that we did there. But today we're here to talk about UAS, the work that we're doing in aeronautics. But while we're doing research work, I want to make sure that you understand that NASA also flies unmanned aircraft. We use them in our work. In our science mission directorate, particularly for earth science, we fly UASs to do monitoring of storms. I mean, what better way is there to fly into the eye of a hurricane than with an unmanned aircraft? For monitoring wildfires, for monitoring gathering effects, data on the effects of global warming. So this is all part of the science work that we do. And actually, even in the aeronautics work, in the project that we just finished for environmentally responsible aviation, we had an unmanned aircraft that was a model of a hybrid wing body, an advanced configuration that we built in association with Boeing. We flew over 100 test flights with that, gathering flight performance data, low-speed aero data, looking at how this aircraft type would actually perform, and what are some of the issues relative to that. So, and unmanned aircraft are also part and parcel of the UAS work that we're doing and the research that we're doing. We're flying those, and of course, as we fly those, that we're a public entity, and so as a federal entity, federal public entity, we can certify the aircraft, the airframes, the pilots. And we're flying under COAs. But for commercial operations, they don't have that ability. There's various ways right now that a commercial operator can fly, but we're doing research that is focused on routine access for a commercial operator into the NAS. And so we're looking at both high-performance vehicles that one can think of would fly very much like a manned vehicle, in all classes actually of airspace. But then we're also looking at very low altitudes and small unmanned aircraft. And so we've broken those 2 pieces of work into 2 parts of our portfolio, one called the integration of unmanned aircraft into the NAS, the other one called UAS air traffic or traffic management. And so between both of these, NASA Aeronautics is investing around $55 million a year in the research. The UAS and the NAS work has been, I think this is the 6th year that project has been going on. It was initially slated to be a 6-year project. We finished that work up, and we're have now advocated and got approval to do another 3 years of work relative to that, and I'm going to talk a little bit about what that work is focused on. So for that work, we have been very closely aligned with RTCA 228 and doing the research that needs to be done to develop those minimum operational performance standards associated with command and control, as well as DAA. And in part of our detect and avoid work, we're doing a whole host of experiments and effort gathering data that will inform the rulemakers relative to issues associated with human factors. So algorithms, pilot displays for ground control stations, cues that the pilot might have relative to warnings or the traffic, the display of traffic and how that's displayed to them. So we're doing a lot of work relative to that. In the last 3 years, we've had 3 major flight campaigns, and each of those flight campaigns is made up of predecessor risk reduction, both fast time and part task simulations, as well as other ground-based work for risk reduction leading up to the flight work. So we're doing a lot of work. We're very integrated, I think, in the efforts that the FAA needs, as well as doing support for other government agencies as well. So we're really a big part of the community. And Lisa Fern right here, who will be, I think, part of the next panel, or at least supporting the next panel, is a key person in our human systems integration work and the research that we've been doing. The other part of the work that we've been doing, which is really fast-moving, it's hard to keep up with it, I think, as Steve can attest to. We were both out at Ames last week with some of our stakeholders relative to the low-altitude operations. It's called UTM. And UTM has really taken on a life of its own. It was really a phrase coined by a researcher out at Ames Research Center to look at enabling low-altitude UAS operations in the NAS just as early as possible, and to accommodate increased stakeholder interest with the highest safety, efficiency, and capacity that we'd be able to maintain. But it's gone beyond that. I think that it's truly now looked at as what's going to be the system that's going to allow low-altitude unmanned aircraft operations in the NAS, allowing operators to submit flight plans for specific missions that they would have, and determine how to safely enable such missions and such commercial operations for multiple UAS operations, either within visual line of sight or beyond line of sight operations. So the thing that is most intriguing to me about this is when you meet with the stakeholder community, the diversity of the commercial operations that they have, and they are so anxious to get started. I mean, we've got, as everybody is aware of, we'll just call them the 800-pound gorillas, the Googles and the Amazons that are off, they're doing their own thing. And I think Tuesday, Amazon announced that they had partnered with the UK to start doing parcel, or looking at parcel delivery within the United Kingdom, and start gathering data relative to that and what it would mean to try to expand that. I expect the same thing out of Google sometime around the first of the year, from what I know of what their plans, and it may even be extended beyond that. They're developing incredible capability. I was with Dave Voss on Tuesday, and he pulled out a small chip or card. I'm not sure what you would call it, tenths of an ounce, I'm sure. And he said, right here, we've got ADS-B in, out, UAT, and 1090 ES, all right here, costing tens of dollars as opposed to tens of thousands of dollars. So the community is really pushing, they're hard charging, and we're trying to stay up, trying to make sure that safety is at the forefront always, and that we're working very closely with the FAA through our research transition team that's been set up for low altitude operations within that community. But it's really exciting, and as much as anything, there is just a galloping industry that wants to operate in this airspace, and there are a lot of different business models of operations within that airspace as well. So where are we at NASA relative to our work? We're finishing up the Phase 1 MOPS for RTCA 228. We're ready to support the Phase 2 MOPS, which in that vernacular is extended operations in Class E airspace, extended operations with manned aircraft. So that would be both manned and unmanned aircraft interoperating together. And to do that, of course, we have capability. We work very closely with the FAA and also with the test sites, or as I was told, I guess, week before last, we're going to start referring to those as test ranges, to exploit their unique capabilities, marry those with the research capabilities that we have. And then we've finished in the UTM work, we've finished the first of 4 capability demonstrations. Each of these is a unique development from going from within line of sight with a couple of aircraft up to many aircraft operating beyond line of sight. And so gathering data, showing how we can do that safely, doing that with the research capabilities that we have developed. And then where are we going? We're actually looking at how to kind of open NASA's aperture at all the work that needs to be done, and making sure with the investments that we're making, which I mentioned earlier, about $55 million a year right now, so it's not an insignificant investment, but making sure that we're investing that in those highest payoff technologies and the highest payoff areas. So we're also looking at autonomy or highly automated operations, what research needs to be done there. Cybersecurity, is that going to be an impediment? Who's really doing that, making sure that the capabilities that we have are brought to bear appropriately relative to cybersecurity. Noise, is that going to be an issue, particularly when we start talking about low altitude and hundreds, if not thousands, of small UAS operating in the same areas? We have a lot of capability in noise and noise research in NASA Aeronautics. And we're also looking at full integration, full integration demonstration, marrying the work that we're doing for the higher performance, higher altitude work with the smaller UAS operating at lower altitudes, and how to do a demonstrator that's going to show how we can safely integrate all of that work together. And then putting together a full integration strategy in conjunction with the FAA on what work needs to be done to show full integration for unmanned aircraft into the national airspace. What is NASA's part, what's industry's part, other agencies' part of that, how everybody's going to do their role, so that ultimately we will open up the airspace for UAS commercial operations. It's going to mean a lot to each of us in our lives as far as from an economic point of view. Do that safely, do that without undue interference to the manned operations that we have now. And NASA's just excited to be part of this. We're excited to be investing in this, and we're really just thrilled to be part of this community and kind of doing our part to make sure that we can safely integrate unmanned aircraft into our national airspace system.
I got one. Hey, everybody. My name's Mark Draper. I'm from the Air Force Research Laboratory, where I actually lead the management of a portfolio, a research portfolio with regards to human autonomy teaming for the Airman Systems Directorate. For those of you who are not familiar with the Airman Systems Directorate but are familiar with AFRL, it's basically the Human Effectiveness Directorate. They renamed it. So I've got to get used to saying Airman Systems Directorate, and it's a bit rough. In addition, I actually lead a Department of Defense-sponsored tri-service project on human autonomy teaming, and the exact focus is how do you enable a future operator to simultaneously manage multiple heterogeneous unmanned systems while they perform various missions. And so that's who I am. And the reason I'm here is because basically I'm representing, I guess, the DoD, which is kind of interesting. So I was coming anyway, and apparently we had some dropouts. So what you're going to get from me is the perspective that I see with regards to where the DoD is heading with regards to unmanned air systems. I've combed through various strategy documents, and basically a lot of it is my perspective based upon working very directly for getting the Air Force vision to be a reality. So I can talk mainly to that, but I guess my main take-home point is these are my thoughts. These are not the DoD's thoughts, so please don't get me in trouble if I say something is a bit out of turn. But all right, so now on to it. So the major DoD goals for UAS, the way I see it, first and foremost is reduced manpower requirements. We need more unmanned air systems. However, we don't have the people to fly them traditionally or anywhere close to that. So it's really interesting because when I first started in this area, it was a big deal to actually have a project that said we have a single operator supervising 4 UAS. Wow, that's a project. Now, every project that I seem to be a part of or just hear about, that's like an ingrained thought. That's like already in there. And so they're moving on to additional capabilities, additional things. But the notion of a single operator who's managing multiple assets is no longer considered this wild vision in the Air Force. It's actually permeated a lot of research. So with that being said, there's a lot of benefits from the Air Force and the DoD for making this happen. But I think that actually does touch really strongly in terms of the FAA and where we want to head and how that relates to getting these aircraft, through the NAS to where we would like to use them. In addition, a part of that reduced manpower requirements is we also need to completely rethink our training. We're looking at training, future operators, not traditional pilots, and how can we do that? And how can we best come up with a proper mix of live, virtual, and constructive environments so that we can do this training in a very efficient format? So that's the first one. The second one is interoperability and modularity. Interoperability is really important because the Air Force, when we got our first generation of UAS, very stovepipe systems, right? They're very proprietary in nature. You can work only with this GCS, with this particular version of this platform, and that doesn't work for the DoD. It's not exactly very efficient. So a lot of push is going for standardization of messaging, standardization of control station designs. Everything is pushing towards this notion of we would like to control a platform even if the GCS we have is not that exact same GCS that should be controlled, ground control station for that unmanned air vehicle. Associated with that also is interoperability within that platform. So we would like to swap out sensors, swap out payloads really quick, and not have it all locked in. This vehicle only does this. So think modularity with the platform and think it with regards to control. The third goal is a big one, and that's increased capability. If you think about this, we're really thinking in terms of long-duration missions, 24/7 missions. This is where autonomy is good. This is where unmanned systems are good, right? You can put them out there. They can look for a long time. They can search for a long time. So we want that. We want new sensors, new payloads, new platforms of all different sizes, operating in all different airspaces, right? So there's a lot of projects going on combining sensors onto a platform and seeing how well they do it at collecting data to support certain missions. So we're looking at a lot of new capabilities with regard to the payload. This ties in really well with another big one, I think, for regard to the FAA, and that's cooperative behaviors of UAS. So we want these vehicles not just to do their individual mission. We want them to work with other unmanned air systems and unmanned ground systems to come up with an adaptive distributed plan to solve a problem and then solve that problem. So thinking in terms of cooperative behaviors, coordinated actions, we're very much about that. Teams, even going into notions of swarms in terms of some projects. I don't know if swarming is, at least from the Air Force perspective, is not a major deal, but perhaps it is with some of the other services. Another big one is comms, systems capability and resilience. More UAS means more comm requirements, more drag on that. We need bandwidth, the sensors, the payloads that we have. going to consume more bandwidth. How are we going to get this? How are we going to get it cheaply? How are we going to get it reliably? Protect against cyber attacks and things like that. That's a humongous area that I'm not familiar with directly, but I know it's important. Fifth one is integration with manned systems. Here's what, I'm not talking about the controller who operates it. I'm talking about people who will be in the same vicinity working with that unmanned system. We have a project within the Air Force called Loyal Wingman, and it has a next-generation fighter flying with a set of unmanned systems either right beside them or 5 miles out, but they're working as a coordinated package. So the human is a teammate of these unmanned systems, and so how do we make that happen? There's Army versions of that, there's Navy versions of that. So this notion of manned-unmanned teaming is really pretty big. And some near-term work that actually relates perhaps more to what you guys are interested in with this integration with manned systems is the work that the Air Force is doing with regards to detect and avoid. We have a sister directorate within AFRL that's looking a lot at detect and avoid algorithms to make that happen. In my particular directorate, we're looking a little bit in terms of the human factors involved with it, not to the extent of NASA is, but small effort. And then lastly, a last big capability gain that we're aiming for is increased survivability and capability in denied and contested environments. Here's where comms go away, right? Comms go away, but we still need to fight through. How are we going to do that? Well, we certainly need collision avoidance capability, Uber collision avoidance capability so they don't run into each other. Self-navigation, we can't rely on GPS. Local problem solving, they got to fight through. They can't check back with the boss to find out, what we should do and what we shouldn't do. And then security and integrity of operations. It's really important. We do not want people spoofing, taking over, jamming their intercommunications and things. So those are big areas within the DoD that we want to take UAS. Most of those relate very strongly to the notion of increasing autonomous behavior, right? All these things I mentioned require increased smarts on the system. And towards that end, there is a Department of Defense community of interest. I don't know if any of you guys are familiar with this or not, but it's led by John Bornstein of the Army, and it's got representatives from all the services, and they're developing integrated roadmaps and issues associated with enabling autonomous behavior throughout the DoD. There are 4 main research areas underneath this notion of autonomy. The first one, think of it as putting in the artificial brain onto the platform. How do you do that? Just an individual platform making it smart. You need to do machine perception, you need to do machine reasoning, you need to do machine decision making, right? So that's the first goal, huge goal. Artificial intelligence, machine learning, all that stuff gets played into that. Second goal, research goal, is scalable teams of autonomous systems. This relates pretty strongly to what I said earlier about we want these things to cooperate. We want these things to know the other one's there, pull information it needs, give information that can benefit the other, work in a coordinated fashion. That's a huge area. But again, machine to machine, we're talking there. The third area is the area I'm personally interested in, and that is human autonomy, system interaction, and collaboration. Here's where we talk about the human being involved with the system. The human controller, first off, right? Because the human controller needs to have a flexible architecture by which he or she can engage at a direct manual level to say what he or she wants done, can go up a layer of abstraction into manager level, supervisor level, where you let the automation go, but you check in, you intervene when necessary, and then even higher to a teammate collaborator level when we get there, to where now you're saying, hey, I can support and assist this autonomous unmanned air system. So we need that flexible architecture with regards to the controller, but also UAS are going to interact with humans that are not their controllers. So other people in the airspace, ATC, other things. How do we make this happen in a reliable manner? So that's a third major area. Dynamic adaptation is a part of that as well. And lastly, a key one here for this group is test and evaluation, verification and validation, right? So as these systems get smarter, we recognize that you need a new way of business in terms of how do you certify these things? How do you test them? How do you certify that they're going to operate safely and reliably in the manner that you want and that they don't make decisions that mess everything up? So all in all, where are we going with regards to UAS and the DoD? Really, civilian and military UAS are headed directly towards more autonomous behavior. with more and more capable platforms operating in all classes of airspace, within particular emphasis in the areas that I mentioned. But that's all I got.
So I'm Steve Bradford. I'm the chief scientist for NextGen. Why am I here? Because Sherry didn't want, no. I'm in charge of the NASA FAA RTTs. The research transition teams, I'm deeply involved in the UTM research transition team with NASA. It's a different animal than most of our research transition teams in that typically NASA does research that goes to industry or it comes to the FAA. My research transition teams seldom have anything to do with products that go to industry. That's something else. UTM is a unique animal, and because it's coming to both of us. Now, I want to be, UTM, the phrase UTM, UAS traffic management, did start with PK, Paramount Kapotokar, for those who are dear close friends of his. And he called it that his project. We realized early on that it's actually the name for how we plan to operate with aircraft and vehicles that, I'm going to use Earl Lawrence's phrase, are always in segregated operations. Segregated meaning that they do not integrate into the NAS. Other people may be flying around them, but they're not vehicles, aircraft, that we wish to inject into ATC. So we have air traffic management, which is about what controllers do with pilots and what pilots do with other pilots in airspace where IFR flights may occur, manned flights may occur, which we take care of. And then we have this whole other class of operations, which for want of a better differentiator today is 400 feet and below, though there will be other opportunities to fly these. These are people we would like to know are being managed, have the authorizations to operate, but we do not want them into the ATC system. So when Ed mentioned that we were working on flight plans, in discussion of flight plans last week, I want you to understand that is not the ICAO 2012 formatted flight plan. We do not want them to file that with us. We're looking at notification and authorization. Notify me where you're going to fly and how you're going to fly. But even then, we're looking at, does the FAA need to know all of these real time, or is this really operator-operator, cooperative behaviors between operators? So it's a different world. This is a lot about how do operators interact with each other cooperatively so that they understand what each other is doing so they can sort of near tactically deconflict, and then what do they do when they deconflict? Sherry wrote a concept for operations in IFR, and we said that you always had a single pilot in charge. We know, and I understand that there's going to be some variations on that, maybe even in integrated airspace. We believe at low altitudes that it'll probably be the norm, that they'll be operating based on a plan. Do I call that autonomous? We tried not to call it autonomous. I think what we want to say is that the operator needs to intervene and be capable of intervening whenever circumstances change. Does that mean that, so that, and we still haven't figured out all that out, so there's some human factors there, but it means that we don't expect them to be sitting there with a joystick and flying the aircraft, but we do expect there to be monitoring and alerting when they have to take charge. So if the status of the airspace changes, they need to intervene. They need to replan. If they're going to have a conflict with another vehicle, we may require them to intervene directly depending on what certification ends up. So we expect to have a lot of autonomy, in quotes, at low altitudes. We expect them to behave with each other. We expect them to tell us what they're doing. And there's a lot of human factors in there, but a lot of that goes towards them. One of the things we need to understand is expectations of alerting. If I turn an airspace hot and say you all got to get out of there, I really need to know what should be my expectations for these operators to actually move. You know, how much prior time? If I'm going to switch an airport and I'm going to change where they can fly, how much prior knowledge do I have to give them and so that they can react and move their operations? We wrote an unapproved white paper. It's been sort of approved, in which we said they would have to be continuously engaged with us. One of our 800-pound gorillas said, well, does that mean every 5 seconds? Does that mean every 10 seconds? And we realized what we probably meant was like 5 minutes, 10 minutes, because humans are still involved. And so there's a lot of work about notification, alerting, and movements. So my key points that I wanted you to take away that this is, UTM is not ATC. UTM is a cooperative, it's a cooperative nature with the operators doing a lot of their own management. We're trying to figure out how that is going to happen. What is our engagement role? What are our expectations for them to change? We do not expect these operators to ever talk to a controller unless they're actually going to go out of UTM airspace and into ATC airspace. If I'm traversing Class B, but I'm below some threshold that Bill sets, don't talk to anybody. But if I have to pierce the airspace where I have active control going on, then we have to have voice. But the rest of the time, so this is a completely new area for us. You know, it's kind of like the planes that have no radio and no transponder, except they actually have to keep, people have to actually keep in touch with us because they want to fly. Those people want to fly where nobody wants to fly. And these people want to fly where, you know, 40% of the territory is already covered by Class B or Class C, so they want to fly below that. So this is a whole different animal. And so I think those are some of the human factors issues, and a lot of them are going to rest on what can the operator do, what can we expect from the operator, and then in turn, what can we build that reflects their ability to operate. So, and with that, I give you 4 minutes for questions, because I'm leaving at 10:30.
Understood. Well, we do have microphones on the sides. If the audience has questions, just a couple minutes here. But thank you to everybody before we end this. I just want to say thanks. I thought all of that was very relevant. I think it provided a lot of the context that we need, and we'll get into details and kind of take some of that information and run with it in the next 2 or 3 panels. So I just first wanted to thank everybody for doing that. I got to say, the question that came to mind during a lot of the autonomy discussions, I was wondering what's Bill Davis thinking about all this? You know, we got plans for autonomous operations or the desires to do this, and it's not clear to me how that's all going to work with an air traffic controller. And the other thing I was thinking of, what Steve said about UTM, you know, you talk about how engaged do we have to be. Well, it's not, you're not talking about air traffic control engagement, you're talking about some other engagement, and we're talking
about the operator being engaged in the operation of the vehicle, because,
Yeah,
you know, a lot
okay.
of these people are drawing things on an iPad
Yeah.
that's flying around. Well, how do I alert them that they have to get on their iPad and change the path?
Yeah. So they don't have, really, there's no FAA involvement in that scenario at all. But FAA has a stake in this, and does FAA, one of the questions I have is, you know, does FAA have research interest in this from the human factors perspective?
Let me jump in. I'd say that maybe no FAA involvement at the moment, but I think most of us can see that there may be some kind of systems integration that will be necessary to allow autonomous integration, autonomous operations to then integrate further into airspace, like Steve mentioned. So there's just a lot of work and a lot of discovery that needs to be done here, and we have an industry that is moving in dog years, if you will. And one of our struggles is that you'll have to understand and manage to is that much of the government still works in acquisition years, which is in multiple year cycles.
Which I like to call reverse dog years.
Yeah, yes. And so dog years or apple years, whatever it is, we're seeing an industry that's just exploding out there with innovation, tons of money, lots of interest, lots of will, including political will, and trying to migrate into a system which is by its very nature, reserved, conservative, slow to move because of the performance expectations on the system are so incredibly high. And so the NASA has challenges and UAS have challenges, and that's why I submit the real challenge is not building them and not flying. Although the flying multiple ones I find to be really cool. I'm interested in that. But intertwining this, and I'm not using the word integration because I'm not sure what the word is. I'm saying intertwining this into the UAS operations into the manned system. That's the challenge, and lots of human factors work to go.
Very good. Those are all very good comments, too. And the last one I had anyways, before we break, if others have questions, but NASA, everybody mentioned UTM and how laden it is with the human factors issues. You have your dedicated HSI effort. I believe that's been largely, or maybe exclusively, SC228 DAA kind of support. Are they not is your human factors group at NASA not involved in UTM, given all the needs for human factors in UTM?
I don't know that they are, that they're deeply involved. Right now, it's the effort that's going on is a little more basic than what their, I think, involvement would entail. But I'm really not aware of that, Bill.
Okay, well, we can address that in the next panel, too, a little bit.
So I don't know if they're acting as human factors experts on paper, but two of the leads in this are actually have a long history of doing human factors at NASA. It's like Tom Prevost, and PK did human factors for us at the Tech Center. So I think through osmosis, or whatever you want to call it, through tactile touch or whatever, human factors are being involved, but I don't think that they've called anything out as explicitly human factors.
Yeah, and I know it often is the case that way. Okay. Do we have a quick question from the audience?
Hey, it's 10:30.
I know it said that. We can, we can, I mean quick, like 5 seconds questions. No more than 11 words. One quick comment by Wes Ryan. That has to switch on, or you can come up here.
Time's up.
Thank you. Appreciate it. So just one quick comment, Bill. I really appreciate you putting this together and all the folks that helped to organize this. From the discussions today, this has been a really great focus on human factors and the interactions between the different groups, NASA, DOD, FAA, doing this type of research. The one comment I guess I would make is how do we continue to do this same type of interaction for all the other research areas that are going on? Because I know NASA is spending money, DOD is spending money, FAA is spending money on R&D. We have the dog year issue of we need the R&D results super quick. We have electric propulsion, we have integrated flight controls, we have all these other areas that are big topics just like human factors that need to be coordinated. And so I guess my general question is it RTT that's doing that? Is it just ad hoc committees like this, or how can we do a more formal interaction between agencies to make sure we're not duplicating spending the same money in different bins, since we're all kind of doing our things independently at the moment. But I really applaud this type of interaction and coordination. Thanks.
I'm not sure what the answer is. Yeah, we'll work on it. We'll take it offline. That's always my favorite answer. But yeah, certainly we need to do it. Speaking of offline, we're going to take a break now. It's 10:30. We're back for panel 2, which is pilot human factors at 11 o'clock. And so half-hour break. And thank you once again to all the panelists. Mission accomplished. That was exactly what we needed. Thank you.